Hi everyone, my name is Manuel Urueña from Independent Physics, and in this video I will explain my published paper MOND as a transformation between non-inertial reference frames via Siama's interpretation of Mach's principle, published last year in 2024 in International Journal of Theoretical Physics and available in arXiv for free. In this paper I show that Milgrom's modified Newtonian Dynamics MOND correction to Newtonian gravity or inertia is equivalent to a more fundamental transformation between a non-inertial local reference frame and the fixed background of the observable universe, complying with Mach's principle. Both Newton's gravitational constant and Milgrom's MOND acceleration parameter or scale constant are substituted for two varying, measurable, physical and cosmological parameters under the justification of Siama's interpretation of Mach's principle, causally connected mass and size of the universe. This Machian interpretation, mass and length scale invariant and free from fundamental constants and free parameters, with the exception of the speed of light as the speed of causality and gravity, is based on relative field intensities of the small and large scale of the universe. It respects the Machian effect from Siama's model, by which, in absence of a background, rotational speed is undefined up to the speed of light. The Machian MOND approximation is a necessary feature of a phenomenological nonlinear theory of modified inertia or nonlinear theory of modified gravity, which incorporates Mach's principle in agreement with galaxy rotation curves. I will first start presenting observational facts about galaxy rotation dynamics. The baryonic mass is observed through luminosity and mass-luminosity relationships, and the rotational tangential velocities of stars and gas through the Doppler effect. There are four important regularities or patterns found in galaxies, which are referred to as the new Kepler laws for galaxy dynamics. First, tangential velocities in galaxies are generally asymptotically flat in galaxy rotation curves, while Newtonian gravity predicts a Keplerian fall-off. Secondly, these asymptotic flat velocities are proportional to the force root of the observed mass, a relationship called the Tully-Fisher law. Thirdly, features in observed mass strongly correlate with features in the velocity profiles, a relationship called the Renthos rule. And finally, Newtonian gravity correctly predicts velocity profiles at the cores of galaxies, and mass discrepancies are observed below a particular acceleration scale, a feature called the Caspy-Halo problem. These regularities do not have a simple explanation within the physical dark matter halo hypothesis. Then, Milgrom developed in 1983 a model called MOND, Modified Newtonian Dynamics or Modified Milgromian Dynamics, as a correction to either Newtonian gravity or Newton's second law of inertia, through a correction factor called an interpolating factor. Milgrom has favored the modified inertia version instead of just modifying gravity. This interpolating function is precisely derived to match the observed patterns of galaxy rotational dynamics described earlier. The interpolating function mu interpolates between a Newtonian regime in which there is no correction to Newton's laws to give the right prediction for planetary dynamics, and the so-called deep MOND regime, through the total acceleration g and an acceleration scale parameter a0, which is a new fundamental constant introduced in the MOND model. Below this particular theta-fitted acceleration scale value of around 10 to the power of minus 10 meters divided by second square, the velocity of stars around galaxies is proportional to the force root of the observed mass, and above this acceleration scale, such as for the case of the solar system, velocities are proportional to the Newtonian square root of mass, so that in the limit of a0 approaching 0, Newtonian gravity or Newtonian inertia is recovered. Progress in fundamental physics has been made in the past by reducing the number of fundamental constants, such as the gravitational acceleration of the Earth and other planets, for a universal gravitational constant, the unification of the speed of light with vacuum permittivity and vacuum permeability, and atomic constants for Planck's constant. Therefore, it is of considerable interest to explore modification of the laws of gravity without the need for more fundamental constants. Milgrom first suggested a possible coincidence between his new introduced acceleration constant with the cosmological constant, and briefly conjectured a possible connection with Mach's principle in two of his papers, but he never developed this idea further. We explained Mach's principle and its implications in a previous video. Be sure to check it out to understand this one. He stated that an attractive possibility is that MOND results as a non-relativistic small-scale expression of a fundamental theory by which inertia is a vestige of the interaction of a body with the rest of the universe in the spirit of Mach's principle, and that the only system that is strongly general relativistic is the universe at large, and that it has been long suspected that local dynamics is strongly influenced by the universe at large and a Mach's principle, but Mond seems to be the first to supply a concrete evidence for such a connection. In fact, the cosmological constant is related to the energy density of the vacuum in general relativity, but another coincidence in orders of magnitudes is that of the energy density of the vacuum with the energy density of matter. Through this reasoning, and together with Sciama's relationship for the gravitational constant, Milgrom's acceleration scale constant corresponds to the gravitational acceleration of the rest of the mass of the observable universe. Performing this substitution, I arrived at the so-called Machian MOND formulation for Newtonian gravity or for inertia, which is shown here. So why is MOND Mach's principle? This Machian MOND formulation, which is equivalent to MOND, contains the same parameters as the Machian modified theories of inertia of Sciama and Heder, which we covered in previous videos. MOND can be thought as a stronger dependence of local dynamics on global parameters, because MOND is nonlinear due to its external field effect, in contrast to Sciama's or Thread's model, which are linear. A decrease in the observable mass of the universe is equivalent to a decrease in inertia, and Machian MOND contains no fundamental constants or parameters except for the speed of light. The velocity of stars around galaxies below the universe's field intensity are computed directly out of a factor of the speed of light through the fourth root of their visible mass, equivalent to the deep MOND regime. The Machian MOND interpolating function respects the scale invariance of mass, length, and time of Sciama's relationship, unlike in classical Newtonian gravity. This means that observables such as velocities do not depend on scaling all masses or all distances. If we double all the masses of the universe, the velocities take the same value. MOND is only length scale invariant in the deep MOND regime, because in the Newtonian regime it reduces to the Newtonian framework. It also respects the Machian effect of Sciama's relationship, by which, in absence of a background universe, substituting the mass and radius of the universe for the local mass and radius, the interpolating function reduces to a simple number which can be set to unity with the appropriate choice of integers within the interpolating function, so that rotation is undefined up to the speed of light. The analogous formal limit in which A0 goes to 0 cannot be made in Machian MOND, because the mass of the universe can never be 0 in the system under study. It can only be the very same mass of the system itself. This agrees with the thought experiment of having two masses rotating around each other in empty space, in which, from a Machian point of view, without an absolute space, the two masses define the inertial frame, and one cannot speak about rotation of any kind. The system can choose between any rotation up to the speed of light. In summary, Machian MOND is a way to prove Mach's principle through a phenomenological explanation of MOND. That is, a way to prove Newtonian gravity and general relativity to be incomplete, due to not incorporating Mach's principle and being unable to explain galaxy rotation dynamics. The Machian MOND interpolating function can be thought to apply to inertial mass or just to gravity as a correction to the gravitational constant. Special relativity relativizes velocities through the Lorentz correction factor with a factor of velocities and the speed of light, but acceleration is required to be absolute for consistency, for instance in the twin paradox. Machian MOND seems to come from relativizing accelerations through a correction factor in a similar way, because it contains a fraction of the field intensity divided by the universe field's intensity. The main question is, where does the Machian MOND interpolating function comes from? We know it must come from a nonlinear theory, but currently only non-relativistic linear theories of modified inertial Mach exist, such as Sciama's or Thread's, which are like gravitoelectromagnetism, linear and not Lorentz invariant. So the interpolating function is probably an effective correction in the weak or linearized limit. This means that in the same way general relativity reduces to the Newtonian gravity law in the weak limit, a complete nonlinear and Machian theory of gravity should reduce to the Machian MOND in its weak limit. The interpolating function may not appear explicitly in the theory, but the acceleration scale of the rest of the universe should appear somehow, in contrast to general relativity, in which solutions to local dynamics do not depend on the mass or size of the observable universe, because they assume asymptotic flatness at infinity. The solution should then come from making general relativity fully Machian. I show here a variety of equivalent formulations of the Machian MOND interpolating function. As final remarks, MOND generally solves dark matter effects in galaxy rotation curves, but falls short in galaxy clusters. MOND does reduce the mass discrepancy observed in clusters, but a mass discrepancy of around 3 to 1 or 2 to 1 is still observed. The mass discrepancies in clusters when using MOND curiously appear at the core of the clusters, unlike in galaxy rotation curves, which appear far away from the centers when not using MOND. Thus, the physical dark matter hypothesis makes more sense in clusters than in galaxies when using MOND. In the same way Milgrom identified that the mass discrepancy in galaxies occur at a particular acceleration scale, Jacob Bekenstein identified that the mass discrepancy in clusters when using MOND occurs at a certain potential scale. A modification based on potential should only affect the low acceleration regime where the correction of Machian MOND applies. Otherwise, it would result in stronger gravity in high potential and high acceleration regime, such as neutron stars, whose dynamics constrain a possible modification of gravity in them. And finally, I attach a derivation of Machian MOND that I have here in my background. Thank you very much and see you in another video here in Independent Physics.